Hi friends, my name is Amita and in this video I am going to discuss about a very important topic of an electrical engineering, that is electrical elements. It's a very basic topic of an electrical engineering, but before understanding the details of electrical engineering, everyone should aware about its basic elements. As you know that human body is consisting of five basic elements. Similarly, whatever machine or a device or any part of electrical engineering, if we are going to study, we should have an idea of an electrical element. So now, without wasting time, I am sharing my screen where I will brief you about the different types of basic electrical elements and the details related to it. So, if you see the electrical elements are majorly classified in two types. One is active element, which is also called as a source, and another is a passive element. Active elements are further classified in two ways: independent type sources and dependent kind of sources. Whereas passive elements are resistance, inductance, and capacitance. Okay, the detail regarding that I will discuss in the subsequent slides. Independent kind of sources are of two types. One is a voltage source and current source. Similarly, the dependent sources are of two types: voltage source and current source. First, I will discuss about independent sources. Voltage sources are further classified in two ways: DC sources and AC sources. And DC sources are of two types: ideal and practical. Similarly, AC are available in two forms: single phase and three phase. And single phase is also of ideal and practical type, and three phase is also ideal and practical type. If I talk about current source are also of two types: DC type, DC again ideal and practical, and AC again of two types: single phase, three phase, ideal practical and ideal practical. Dependent voltage and current source. Voltage source can be independent current control voltage source, and it is a voltage control voltage source. Similarly, the current source can be of current control current source and voltage control current source. One by one, I am going to discuss in detail. The first thing is active elements, and it is also called as in sources. So we can explain it is the element which can provide some energy to the circuit. Okay, or you can say the another way of defining the sources are nothing but the device which converts one form of energy, that is chemical energy, solar, hydro, thermal, etc., into electrical energy. Okay? Electrical energy. For an example, like your battery, your cell, your diesel generators, all these are the example of an active elements. Okay. Now, as you can see here, I have discussed about one term, that is circuit. Okay. So what is circuit? Circuit is nothing but it is the connection of an electrical element. It is the interconnection of an electrical elements. Okay, through which a current can flow. Okay. Now let us come to the next type of element, that is passive elements. That is passive elements. So what do you understand by passive element? As the name indicates, these elements are either stores the energy or consume the energy. And for an example, resistance, inductance, and capacitance are an example of an passive element. Resistance, basically it consumes the energy, whereas inductance stores the energy in terms of magnetic field, whereas capacitance stores the energy in terms of electric field. So these are the two basic types of electrical elements. Okay. Now let us talk about the sources, types of sources or active elements. Okay. So under the active elements or type of sources, we have seen two kinds. One is a independent sources. Independent sources. So as the name indicates, these are the sources. These are the sources of electrical energy whose output is independent from the change in circuit parameters. I already told you that what is circuit? Circuit is nothing but it is a combination of interconnection of electrical elements. And the value of those electrical elements are called the circuit parameter. Suppose one circuit is consisting of an free number of resistances of 5 ohms, 10 ohms and 15 ohms, and it is connected to an DC battery, then 5 ohm, 10 ohms and 15 ohms resistances are called the circuit parameters. Okay, so this is something about the independent sources. Okay, now the second kind of classification was dependent sources. As the name indicates, these are the sources of electrical energy whose output depends on change in circuit parameters. Change in circuit parameters, whose output depends on change in circuit parameters. Okay, so these are the type of sources. Now one by one we will discuss in detail about these type of sources. So first I am going to discuss about independent sources. So let us discuss about independent sources. So I already briefed what is independent sources. Now independent sources, you know that it can be further classified as a voltage source and current source. So voltage source, it is a source which can provide the constant voltage to the circuit, irrespective, because it is independent sources, so irrespective of change in circuit parameters. Okay. Now next is current source. As the name indicates, it is a source which can provide the constant current to the circuit irrespective of change in circuit parameters. Okay, so that is the current source. Now let us discuss about the further classification of voltage source. Voltage source, please mind it, I am talking about independent type. Now voltage source can be further classified as a AC source and DC source. You know that there are two kinds of electrical supplies available. One is a AC source and another is a DC source. So this source will provide the AC type of voltage to the circuit. Okay, and it can be further classified in two ways. One is called as a single phase AC source. ठीक? So इसी के अंडर में है one, this is 1.1 and another one is 3-phase AC voltage source. ठीक? This provides single phase AC voltage to the circuit and this provides 3-phase AC voltage to the circuit. Now the second thing is DC source. This source will provide the AC, not AC, this source will provide the DC type of voltage to the circuit. Okay, so that's the AC type and DC type. Now further after AC source में we have seen single phase AC source. This can be of two types. One is ideal and another one is practical. Now ideal single phase AC source, it is the source whose internal impedance is 0. Okay, whereas practical single phase AC source, it is the source whose internal impedance is of less value. Okay, so that is the single phase AC source. Okay, now let us talk about three phase AC source. Again, it is of two types. One is ideal type three phase AC source. Its internal impedance is Z. Okay, whereas practical type three phase AC source, its internal impedance is of less one. Okay, so this is something about three phase AC source. Now let us talk about DC source. DC source, again it is of two types. One is ideal DC source and another is practical DC source. Okay, so it is the source whose internal resistance is Z. Okay, whereas practical source, it is a source whose internal resistance is of less value. Okay, now one important thing, if I want to represent the symbol, ideal DC source symbol will be like this, or you can make like this. Okay, so this is the symbol for ideal DC voltage source. Okay, and if somebody is asking its characteristic, if I plot the ideal DC voltage source independent type characteristic, then at x-axis if I take I, at y-axis if I take V, then since it is an independent DC type voltage source, it means it will provide a constant voltage irrespective of change in circuit parameters. तो change in circuit parameters होगा तो उससे current change होगी. That means irrespective of change in current, it will provide the constant voltage. So what is this? This is the VI characteristic. ये क्या है? VI characteristic of a ideal voltage source. और ये दोनों क्या है? Symbol. Similarly, if I plot the practical DC voltage source में I have to connect one series resistance Rin, which will be called as an internal resistance. So this is the symbol of an practical DC voltage source, where we connect a single resistance of a less value in series with a voltage source. So these are the symbols. Okay, and if I plot the characteristic, at x-axis again I will take I, at y-axis I will take V. It will be slightly drooping characteristic. So it will not be constant, but it will be slightly drooping. So hard line is representing the ideal characteristic and dash line is representing the practical characteristic. Okay, so this is what VI characteristic of practical DC voltage source. Okay. Similarly, I can make it for here also. Let me enter the slide. Okay, here also I can make single phase AC voltage source ideal type. I already defined. If I try to make it symbol, it will be like this. AC source is represented like this. So this is the symbol for AC ideal type single phase, and if I draw the symbol for practical type, in practical type I have to connect one Zin in series with this AC voltage source. So this is the plot, or this is the symbol for an practical type single phase AC voltage source. If I plot the characteristic of this is I. Please mind it, this will be IRMS and here it will be VRMS, because in case of AC, as the AC is alternating in nature, so always be represent its electrical quantities by its RMS value. So its RMS value will be constant. And in case of practical source, if I write here IRMS, if I write here VRMS, it will be slightly drooping. So this hard line for ideal and this dash line is for practical. ठीक? तो ये क्या है? This is symbols, okay, and this is VI characteristic. So this is something about single phase AC voltage source. Now similarly, I can draw the symbol for three phase also. So the next is three phase AC voltage source. It is also of two types. One is a ideal type. So ideal, and here I will make the symbol and characteristic for practical. So ideal type and practical type mein, if I make this kind of symbol, this is R phase, this is Y phase, and this is B phase. So this is the symbol for a ideal three phase AC voltage source. Whereas if I plot the practical, then Z in R, this is R phase, then this is Y phase, and Z in Y, and this is Z phase, not Z, P phase, and here it will be Z in P. So this is the symbol for an three phase practical AC voltage source. Okay? So we have seen the symbols and characteristics also. Now the next type of source under independent category, that is a current source. Okay, I already explained what is the current source. Now we will see its type. It is of two types, AC current source. As the name indicates, please mind it, we are studying only independent sources. AC current source, it can provide the AC current to the circuit. Okay, constant AC current to the circuit. Constant का मतलब ये है constant RMS value of AC current to the circuit. It is of two types, single phase AC source. कौन सा है? Current. Okay, so this provides the single phase AC current, single phase constant AC current. Constant AC current मतलब RMS value, root mean square value to the circuit. Okay. Now, if somebody is asking for its symbol, so single phase AC current symbol will be like this. Only there is a difference. In place of V, here I will write I. So this is the symbol. And if somebody is asking the characteristic, so if you want to plot its characteristic, this is the symbol and this is the symbol, and VI characteristic, it will be like this. At x-axis we will take V, at y-axis I will take R, and it will be constant. Sorry. Yeah. So we were discussing about single phase AC source. Now, single phase AC source can be of two types. One is a single phase AC current source ideal type. Okay, and second one is single phase AC current source practical type. Okay, so single phase AC current source ideal type, what it means, its internal impedance is infinite, whereas if I want to plot its symbol, it will be like this, high like this. Okay, if I want to plot its characteristic, at x-axis I will take V, at y-axis I will take I, and it will provide in constant. Please find it, this is VRMS and this is IRMS, so it will give the constant RMS value. Okay, now if I plot the practical type, may we have to connect Z in, okay, and we have to connect Z in parallel with the current source. Okay, so this is the symbol for a practical type of. If somebody is asking its characteristic, then at x-axis it will be Vrms, at y-axis it will be Irms, and it will be slightly drooping characteristic because of a internal impedance. So practical type of source, single phase AC current source practical type, having high value of internal impedance. Ideal infinite or practical high value of internal impedance. Okay, so this is for ideal and this is for practical current source. Okay, so that's it for a single phase AC current source. Now let us talk about three phase AC current source. Okay, again, as the name indicates, this can provide three phase AC current to the circuit. Okay, there are a lot of advantages of supplying three phase current to the circuit. One, again it is of two types. One is ideal and second one is practical. So ideal three phase AC current source having internal impedance infinite. Okay, so if I plot its diagram, this is IR, this is IY, and this is IB. Okay, and if somebody is asking its characteristic for phase Vrms and Irms, it will be constant. For R phase ऐसा ही रहेगा, for Y phase भी ऐसा ही characteristic बनेगा, and for B phase भी ऐसा ही characteristic बनेगा. Now let us talk about practical three phase AC current source. Practical three phase AC current source. Okay, which can provide in three phase AC supply. Again of two types, ideal and practical. Ideal matlab it will have zero internal, not zero, it will have infinite internal impedance. Okay, so how to plot infinite internal impedance? Now I plot its characteristic, symbol, it will be like this. Oh, okay. Now let us talk about practical three phase AC current source. It is having high value of internal impedance. How to draw its characteristic? Like this, parallel with Zin. This is Zin-R. This is IR. Okay, ये क्या है? IR. So this is IR, and similarly for IY, and in parallel with Z in Y. Okay, and here also IB parallel Z in B. So this is the diagram. So I have completed the independent sources. Now let us come to the dependent sources. I already told you there are two types. One is voltage source. It is the source which can provide the voltage to the circuit which changes with the circuit parameters. Means if you change any of the parameter of a circuit, the output voltage from it is going to change. इसमें there are two types. One is dependent voltage source are of two types. One is current controlled voltage source, which is CCV. It is the source which provide the voltage to the circuit whose output can be changed by change of current in any element of the circuit, in any element of the circuit. And what is the symbol? The symbol will be like this square plus minus alpha into R, where alpha is a constant. This plus minus is showing that it is a voltage source, and this I is showing that it is a current controlled voltage source. Now, let us talk about the next kind of dependent voltage source, that is voltage controlled voltage source. Okay, as the name indicates, in short we can write VCVS. As the name indicates, it will provide in voltage to the circuit whose output can be changed by changing any voltage, by changing voltage across any element of the circuit. Okay? So how you define? It will provide the voltage to the circuit whose output can be changed by changing voltage across any element of the circuit, and it is represented by again the square symbol plus minus alpha into V. So this is the symbol for an voltage controlled voltage source. Now the next is current source. कौन से current source? Dependent type. Okay. Again two types. One is called as an current controlled current source. That is CCCS. It can provide the constant current, not constant current. It can provide the current to the circuit which can change by changing current in any element of the circuit. Okay, its symbol will be like this alpha R. So like this. Now at last we are going to discuss voltage controlled current source. As the name indicates, VCCS. It will provide the voltage, it will provide the current to the circuit whose output can be changed by the change of voltage across any element of the circuit. See? Again, it will be represented like this, alpha into V. So, it is a voltage controlled current source. Okay. Now, at last, I will tell you the passive elements. Passive elements mein, I already told you there are three basic elements. One is resistance, another is inductance. So what is resistance? You can define it is the obstruction provided by the material to the flow of current. Okay, it is the power consuming element. Next inductance. So it is the power consuming elements. Okay, its symbol is like this, R, and this is the symbol, and unit is ohms. Okay, now come to the inductance. It is the property of the material due to which it opposes the change of current. It doesn't oppose the flow of current, but it opposes the change of current. It is the power storing element. It stores the power in terms of magnetic field. Symbol क्या है? Like this, This is the symbol and its unit is Henry. Now at last, capacitance. It is the property due to which it opposes the change of voltage. Okay. It is also a power storage element. Power storage element which stores electrical energy in terms of electric field. Okay, its symbol is like this and its unit will be farad. Okay, so this was the description related to the electrical elements. I'm stop sharing my screen. So my dear friends, I hope whatever information I have shared in this video related to a very basic thing of electrical engineering, that is the electrical elements, will be very useful for you. If you want to learn more related to an electrical and electronics engineering, then keep watching my videos. Thank you. Goodbye.